We finished planting the last of the oats for the year, so now it's time to get everything cleaned out and changed over to run some Siberian millet. The first thing we need to do is drop the air cart manifold down so we can get at the clean out plate and push the auger underneath. This thing is kind of heavy and it's supposed to slide up and down the rails on 4 roller bearings, but they're not in real good shape anymore and it's not worth the time and money it takes to fix it for the few times a year you actually have to do it. The auger is one of the better thought out features of this cart. It functions as both a loading auger and an unloading auger, so you can either load the cart with it or you can flip it around, stuff it under there, and unload the cart with it back into a truck as well. A lot of people use separate augers or conveyors to load or unload these air carts, but I'm usually doing all this myself, moving equipment around and such, so every extra piece of equipment that needs to be moved ends up taking a lot of extra time, so I just use the one that's on the air cart. There's not a lot of oats left in here, but I did overfill it a little bit just because I didn't want to sell myself short and then have to reset up and add more. It'll clean itself out about 99% of the way. There's just a couple little ledges inside that seed sits on, so you crawl down in there and push it off. I normally wouldn't worry too much about a little residual of the old stuff in there, but since we're switching crop and need to get a new calibration run on it, we need to make extra sure that the new seeds are the first things out in the meter roll. Otherwise, if we contaminate it with the old different size seeds, we'll get bad calibration numbers. There are no remote control electric roll tarps on this place. Gotta do it the manual way. Crawl up there and strap it down. I wanted to get this stuff unloaded here because this is where the truck and the air seeder are going to part ways. The truck's going to go one direction and head back to the shed because chance of rain here in the next couple of days. And the tractor and air seeder are going to go the opposite direction and get a little bit closer to the road because the millet seed is in bags and we need the seed and the bobcat. And I don't want to drag all that equipment all the way back in here. So we'll finish getting this packed up and then we'll play a game of musical vehicles for a couple of hours. We are in the new spot. I got the truck back in the shed where it belongs, and we've got the bobcat and the dump trailer moved over, and we've got the flatbed with the seed on it moved over. Millet seed is a lot smaller than oat seed is, and it's a lot more dense, so that bag hanging there is 2,000 pounds. The size and the density of the seed matter a lot in this type of metering system, so that's why we have to make sure we get good calibration numbers because they're going to be very different than the ones for oats. I'm not going to completely rule out the possibility that we might get rained on again. It won't be a useful amount of rain, but it's best if this stuff stays dry, so it's definitely not what you want when you're trying to load this stuff. Now we got to run the calibration, and to do that we need to put the monitor in calibrate mode. I mentioned that seed size and density matter a lot in the calibration, and the reason for that is what you're really targeting on the average is a population density. The trouble is the air seeder has no concept of how many seeds individually are going through it at any given time. So we end up using a series of good enough approximations. We know about how many seeds of a given product are in a pound, and therefore we can figure out how many pounds we want per acre to target a plant population. So the way this works is you put these bags under the meters, and then you push the calibration button and it will rotate the meter rolls. And while the meter rolls are rotating, the controller on the air cart is keeping track of how many rotations have occurred. When enough product gets into the bag where you think you run the risk of dropping the bag and spilling it all, you take it off and you weigh it. And when you get the weight on it, you go back in and you tell the controller how many pounds was in the bag. In our case, the bag weighed right at 30 pounds, so we tell it that the bag weighed 30 pounds, and now the controller can equate a certain amount of weight to a certain number of rotations of the metering roll. So from here, the main purpose of the controller is basically just to be a linear equation solver. If the wheel speed doubles, it means you're covering twice as much ground, so the speed of the metering roller has to double to accommodate for that. Because it's a simple linear equation, for years and years it was very common practice to do this with sprockets and chains and ratios mechanically rather than electronically with motors. The advantage of the variable rate nature of the electronic version is if I get up on top of a sandhill or something where I know that nothing's going to grow anyway, I can just hit a button and drop the fertilizer rate down a bit. Like I said, it's a good enough approximation. It isn't exactly counting seeds like a planter or a higher precision piece of equipment would do, but it's useful enough to work without a whole bunch of maintenance issues and expensive instrumentation that would be required to actually count the number of seeds. So with that done, we are set up and ready to plant millet. We will run a couple hundred acres of that. Thanks for watching.